Alright, last batch of problems starting from number 7. So we got 100 children who are asked to make a note of what they drank, either water, coffee, or fruit juice, and we need to represent the information on a Venn diagram. So water, coffee, fruit juice, universe. Here we go. One child drank only water. Well, the only water part is there. 6 children drank only coffee. 8 children drank only fruit juice. 5 children drank all 3. 7 children drank water and coffee only. So that's where the water and coffee circles are overlapping only. So we put 7 in there. 53 children drank coffee and fruit juice only. So there's a full 53 in that region. If that word only didn't appear, by the way, then we're saying that this total overlapping region is 53. But when it says only, it means only the outer part. And lastly, 18 children drank water and fruit juice only. We've now represented the information on a Venn diagram. How many children drank none of the above? Well, none of the above is the region on the outside. So let's work out what that x is. We know we have a total of 100 children. If I add up these 7 values, I get 14, 19, 37, 88. Is that right? Let me do that again. 8, 14, 19, 37. Oops. 98. I get 98. So there's only 2 kids left on the outside. So only 2 kids drank absolutely nothing at all. A child is chosen at random. Find the probability that they drank coffee. So how many total coffee drinkers are there? So 6 plus 7 plus 5 is 18, plus 53 gives us 71 out of our 100 kids. You can express that, of course, as a decimal if you prefer, or even as a percent, your choice. Part double-eyed, water or fruit juice, but not coffee. So water or fruit juice, that's everything inside the water or fruit juice circles. Let me just signify that for you. Everything inside this region, but not coffee, it says. Oh, so we got to exclude the 7, 5, and the 53, and we're dealing only with 1, 18, and 8, giving you a total of 27 out of 100. Yes, of course, you can convert that to a decimal of 0.27 or 27%. And lastly, no fruit juice, given that the child did drink water. Well, if we knew that they drank water, then they must be inside the water circle. So how many kids in the water circle? Let's see, we've got 31 in the water circle. So that's our new denominator. We're no longer looking at all 100 kids. We're only looking at the children who drank water because that's being given to us. How many of them did not drink fruit juice in this water region? Only the 1 plus the 7, only the 8 out of 31. Alright, part D. 2 children are chosen at random. Find the probability that both children drank all 3 choices. Now, selecting 2 things is the same thing as selecting 1 thing followed by selecting a second thing without replacing the first. So, how many children drank all 3 choices? Well, let's choose the first child first. There is a chance, 5 out of 100, that that first kid that you chose is one of your 5 who likes everything. Now that that kid has been selected, and you're not putting him back because you're selecting a second child, there's only 4 kids left who like everything, and you don't have 100 kids in there anymore. There's only 99 kids left to choose from. And so we do 5 over 100 times 4 over 99, and we get 0.00202. And that's to 3 significant figures. I think I'll leave that as a, maybe if I try changing it to a fraction, math fraction. Oh, 1 over 495 is actually not all that bad of a fraction either. So either of these answers will be just fine. Number 8. In a survey of 52 students, there's 30 who study Spanish. That's a total of 30 who study Spanish, and 15 who have computers. So the number of computer users, let's see, study Spanish, have computers, it's a total of 15 have got computers. Alright, 7 of the students who study Spanish also have computers, so we put 7 in here. Now we should be able to fill in the rest of the diagram. 7 plus what gives us a total of 30. So 7 computer users and 23 who don't have computers, giving you a total of 30 who study Spanish. There are 8 who do not study Spanish who do have a computer, to give us a total of 15 computers. I can see that the total number of students in the survey is 52. 30 of them study Spanish, which means that 22 do not. Alright, of the non-Spanish speakers or studiers, 8 have got computers. Because there's 22 total, it must mean 14 do not have a computer. And how many total do not have a computer? It looks like 37. We actually could have gotten this 37 earlier on by subtracting the 52 and the 15, knowing that we have a total of 52 students. Alright, so we've completed the table. By the way, please note the word copy. When you see this, it is expected that you will copy it onto your lined IB paper. Otherwise, you will not get credit. Because if you fill things in directly onto the page, when it says copy, sorry, none of the stuff on the question page is going to be marked. Part B. We now need to draw and label a Venn diagram to illustrate this information. So S are the ones who study Spanish, C the ones who have a computer, and they're inside the universal set of all 52 students. So we can see that there's 7 who study Spanish and have a computer, so they go in the middle here. There's a total of 30 Spanish studiers. 7 of them have a computer and 23 do not. There's a total of 15 computer users. 7 of them study Spanish and 8 of them do not. And if you add this all together, this gives you a total of 38 students. But wait, we're supposed to have 14 total students. We're supposed to have 52 total students. That's because the other 14 of them we see do not study Spanish and they do not have a computer, which means that they are on the outside of the Venn diagram like so. Alright, now then, we need to describe in words the set represented by C union S naught. So C, these are the kids who've got computers. So the students who have computers, that's an or, isn't it? Or do not study Spanish, because it's S naught. Part D. Now we need to find you see the N in front? This means the number in this set. How many people are there? How many students do take computers do have a computer or do not study Spanish? Okay, so when we're dealing with an or, we don't need to worry about region of overlap. We're going to keep everything. So we're dealing with all of the kids who have a computer or do not study Spanish. Let's shade everything outside the Spanish circle. In other words, we've chosen these 14, these 7, and these 8. Those are all of the students who either don't study Spanish or do have a computer. That's a total of 29 for Part D. Alright, Part E. A student is selected at random to attend a computer workshop that is given in Spanish. Well, I'm going to presume that we're selecting from all of the 52 students, even though some of them probably wouldn't do very well in such a workshop. But it says a student is selected at random. What is the probability that a student has a computer and studies Spanish? Well, we know that there are 7 such individuals out of the 52 that we were selecting from. What about Part B, or Part II? Has a computer. There's a missing H here, isn't there? Has a computer, but does not study Spanish. So has a computer, but does not study Spanish. I think that was the 8 here, wasn't it? There were 8 such students out of 52, and that will reduce to 2 out of 13. Has a computer if he or she studies Spanish? That's an old IB question. They now always use the word given, but it's a pre-existing condition. So we've given you that they are a Spanish studier. Well, how many Spanish studiers were there? There were only 30 of them. So our new denominator is 30. We're only looking at the Spanish studiers. How many of them have a computer? I think it was 7, wasn't it? 7 of those 30 Spanish studiers have got a computer. 7 over 30. Question number 9. In a club with 60 members, everyone attends either drama or sports, or both. So if you imagine our Venn diagram, there's nothing on the outside. We've got drama and sports, but everybody is involved in at least one of those activities, so there's 0 on the outside of those circles, but inside our universe, of course. So there's a total of 60 members inside these circles. 48 of them are in the drama circle, and 44 of them are in the sports circle. Well, if you add those together, that's a total of 92. Well, 92, but we're only supposed to have 60. So these 32, the difference is the excess, then they must exist in both circles simultaneously. We must have counted those 32 twice. Now, with only 48 members in drama and 32 accounted for already, that leaves 16 here. With 44 people in sports and 32 accounted for already, that leaves 12 there. And now we've completed our Venn diagram. If you add up the 4 numbers, you will see that indeed they do add up to our full 60 members in the club. Part I, the number of members who attend both drama and sports, we can see is 32. Part I, the set represented by, okay, so these are all the people in drama and sports, not, so we can say the members who are not in both drama and sports. We're just looking for the people who are not both of them. And lastly, what is the probability that a member selected at random, so we're selecting from all 60, attends for drama only or sports only? So here's drama only 16, sports only 12. That's a total of 28 people out of 60, and that reduces to 7/15 who are attending only one of the 2 activities. Now the problem continues and says, the club has 28 female members, 8 of whom attend for both drama and sports. Okay, so let me just think about this. So of our 60 members, 28 of them are female, and 8 of them attend both drama and sports. Wow, this is going to get complicated maybe. Let's see how we go. What is the probability that a member of the club selected at random is female and attends for drama only or sports only? Well, let's see. We know that everybody in the club belongs to the circles, right? They all take either drama or sports or both. So all 28 of our female members are inside the circles somewhere. If you imagine these females, and there's 8 who takes both, that must leave a total of 20 who are in only drama or only sports. So there's a total of 20 members out of the total of 60 members who are amongst our 28 females, but they are not the ones taking both, meaning they're taking only one of the 2, and that reduces to 1/3. And lastly, is male and attends for both drama and sports. Well, if there's 28 females and there were 60 total members, we know that we're dealing with 32 males. So it's a total of 32 males. And the male, he attends both drama and sports. Let's just remember for a moment that we had 32 people who were taking drama and sports, 8 of whom are female. So of our 32 males, that leaves only 24 of, let me start again. Of the 32 total members who are taking both drama and sports, 24 of them are males and the other 8 are females. So we're still selecting from everybody in the club, so 24 out of 60, and that reduces to 2/5. And the very last question, number 10, says we need to show our method clearly. Well, of course, we would always do that, particularly because you're being marked on communication, right? Alright, here we go. A box contains a bunch of colored light bulbs, green, red, and yellow. You're already getting a feeling that we're going to have multiple selections. I don't know, we'll see. Alright, one light bulb is selected, and we put it into the light fitting. What is the probability that the light bulb selected is green? Well, we've got 5 green out of 10 light bulbs. That's 1/2, 50%, 0.5. Not green? Well, it must be the complement of this. Or you could argue that must mean it's red or yellow. There's a total of 5 out of 10. Again, 50%. So 50% are green. That must mean 50% are not green. Now, we've already used that first light bulb because we put it into the light fitting of room A. Now let's move on to part B, where we're now selecting a second light bulb. We didn't replace the first one because it's now put into the light fitting of room A. So we've now already got 9 bulbs to choose from. Okay, here we go. The second light bulb is green, given that the first light bulb was green. So let's have a look at the tree diagram. It's green, red, or yellow. And then my second one is green, red, or yellow, green, red, yellow, green, red, yellow. Alright, in this question, part I, we have given you what happened first. We've given you the prior event. We've told you that you have walked along here and that you have selected a green in your first selection. So, we're no longer at the beginning. I've told you that we have come here. This has been given to you. You're here, definitely. What is the probability that the second light bulb is green? Well, remember there's only 9 light bulbs left, and we already chose a green, so 4/9 is the answer. Part I, both light bulbs are not green. Wow, both light bulbs are not green. So none of these possibilities are in play, because the first one was green. Alright, here we go, red, oh no, green, no, that doesn't work. Red, red, this one. Red, yellow, this one. And yellow, green, no, that's got a green. Yellow, red, yellow, yellow. Alright, so we got these 4 possibilities that we need to add together. So let's just fill in what we know. This was 5/10, and I have 3 red, 3/10, and yellow, 2/10. Alright, if we chose a green, then it doesn't matter. We're just looking for both of them not being green. If the first one was red, there's only 9 balls left, or 9 light bulbs left, 5 of which are green. Only 2 now are red, and of course I've still got, I've still got 2 of the yellows inside in the box. And the last 2 possibilities, if I've already drawn a yellow, there's only 1 left, but I've still got all 5 green and all 3 red. So now let's multiply up the probabilities that interest us. 3/10 times 2/9 plus the next one, 3/10 times 2/9. The next one, where both are not green, 2/10 times 3/9. And the last possibility, 2/10 times 1/9. Alright, let's do this on the calculator. So 3/10 times 2/9 plus 3/10 times 2/9 plus 2/10 times 3/9 plus, and lastly, 2/10 times 1/9. And we get 0.222222222. Come on, let's change it into a fraction. With a repeating decimal like that, I bet you it's a pretty easy fraction. There it is. 2/9 is your answer for part II. And part III, one room has a green light bulb, and the other room does not have a green light bulb. Well, okay. So that would mean that we've got green and then red, or green and then yellow, or we've got red and then green, and that's all, right? We need to have at least 1 green. So let me just get rid of these old ones that I don't want anymore. Okay, so here's green and something else. Here's red and green, and here's yellow and green. So we're now going to be adding these 4 possibilities together. So let me just finish the tree diagram up here. I've still got my 3 out of 9 reds and my 2 out of 9 yellows. Okay, so I'm going to multiply this path first, which is 5/10 times 3/9. And then I'm adding it to the next one. Next path is 5/10 times 2/9. next one I'm adding it to is this one, 3/10 times 5/9. And lastly, I've got the one at the bottom, 2/10 times 5/9. And my final answer is looking like a lot like a repeating decimal. Let's change math, fraction, and we find out it's 5/9 as your answer to part III. Okay, part C. A third light bulb is selected, meaning that we've only got 8 light bulbs left. What's the probability that all 3 rooms have got green light bulbs? Well, we had 5 at the beginning out of 10, but then only 4 left out of the 9 remainders, and then now there's only 3 greens left out of 8. So let's work out what we get then. 5 over 10 times 4 over 9 times 3 over 8 gives us, and well, we can write it down as 0.0833 to 3 sig fig, or we can try converting it into a fraction because it does look like it starts to repeat, and we get 1 over 12. Okay, 1 over 12. Part II. Only one room has got a green light bulb. Well, this could be that the first room has got a green light bulb, so that's got a chance of 5 over 10. And then the second room does not have a green light bulb, so there's still all 5 of those non-green light bulbs left out of the 9 remainders. And then when we get to the third room, we've already taken one of our non-green light bulbs. So of the 5 that we had that were either red or yellow, there's now only 4 left out of 8. This is if the green occurred in the first room. Now we need to add that to the possibility that the green happened in only the second room. So we had the 5 red or yellow in the first selection, and then we've got the green, which we said is going to be in the second room. There are 5 greens left out of the 9 remaining bulbs. And now because we've already taken a non-green one at the beginning, then there's only going to be 4 non-green ones left out of the 8. And let's suppose that the green that we had was in the third room. So we've got one of the 5 reds or yellows out of 10 for the first room. There's only 4 reds or yellows left out of 9 for the second room, but we've got all 5 remaining greens out of 8 for the third room. Okay, so we've got 5 times 5 times 4, 5 times 5 times 4, 5 times 5 times 4 in the numerator, and we've got 10 times 9 times 8, 10 times 9 times 8, 10 times 9 times 8 in the denominator. So the product of this will be the exact same as this, and as this we're multiplying the same numbers on the top and the bottom. So how about I just work it out once and then multiply it by 3, because I'm adding the same thing to itself 3 times. So 5/10 times 5/9 times 4/8, and then I'll take that result and multiply it by 3, and I'll convert it into a fraction, and we get 5/12. Or, of course, if you like it as a fraction, you can write it as 0.417 when we round to 3 sig fig. And the last question on the review, at least one room has a green light bulb. I've told you how to handle at least situations. Your best way of doing the probability of at least one would be equal to 1 minus the probability of not at least one. And not at least one is saying the probability of having no green bulbs. So how can we get no green bulbs at all? Well, the only way that can happen is if we did not draw a green on the first time, we drew one of the 5 reds or yellows, and then we drew one of the 4 remaining reds or yellows on the second draw out of the remaining 9 bulbs, and on the third draw there's only 3 remaining reds or yellows out of the 8 remainders. So let's do 1 minus that total. 1 minus 5/10 times 4/9 times 3/8, and we end up getting 0.917, or I can change it into a fraction, and I get 11/12 as my answer to part III. Okay, good luck studying for the quiz. See ya.